It's Christmas again, and we've got a whole bunch of new toys in the shop. Merry Christmas, and welcome back to Cloud 42. I'm James. You haven't seen much of me for a while, and that is partly because I've been trying to get caught up and on top of PC board production and shipping, and partly because I have been spending a bunch of time preparing for some future projects. It being Christmas, I thought it might be fun to open some Christmas presents and take a look at a few new things here in the shop. When I was a kid and my family gathered around the Christmas tree on Christmas morning, my parents always made us open our gifts from the smallest to the biggest. And it turns out that not only is that a great method of prolonging Christmas morning and enjoying it together as a family, it turns out it's also a great narrative device for a YouTube video. So we are going to do the same thing here. Oh, isn't that cute? Look, somebody made nice little name tags for the gifts for the shop. Nice. Without further ado, got a package of Knipex pliers. These are their adjustable plier wrenches. I don't know if you're familiar with these. If you've been around YouTube or the maker community, you have to have seen these. It's like a crescent wrench, except that it's like a channel lock. So it's something between a channel lock and a crescent wrench, where you can slide it along to a position and then the thumb screw pops up, and then you have it set to a particular size and you can squeeze it down on a nut or on anything, and the jaws stay completely parallel, unlike a channel lock. They stay parallel like you would have with an adjustable wrench, but you can grip firmly onto the flats so that you don't end up stripping it or having to sit there with your thumb on the wheel and run it back and forth. And so you get a nice clean grip and a very, very powerful grip with a lot of gripping force with the jaws parallel. And this is something that I could never really justify. They are pretty expensive, but you know, as a Christmas gift, something to treat myself and treat the shop, I figured it was time to go ahead and pick up a set of these. Also because I also picked up an Oxy-Acetylene Torch, and I didn't have a set of wrenches the right size to really conveniently tighten the fittings, and these work great for that application. So I figured it was probably about time, and so I picked up the 3-piece set. This is the 180 millimeter, 250 millimeter, and 300 millimeter. And these are not cheap, I'll admit, but they're beautiful tools, and they operate so smoothly, and they are designed so well. Made in Germany. Really could not be happier with these. Well, you know, when you're starting from the small gifts and working up on Christmas morning and the first package has Knipex in it, you're doing well. What do you think this is? I finally decided it was time to invest in some proper drills. These are Chicago Latrobe. That is one of the brands handled by the Greenfield company. These are made in the US, and these are screw machine length drills. So these are not jobber length. These are the shorter screw machine length drills, or sometimes just called short drills. And they are a lot shorter than a jobber length drill, and so it makes them a lot more rigid, especially in the smaller sizes. So instead of having a big long drill that is going to flex, it's much more rigid, and often you don't have to spot with these. They work great in the tailstock of the lathe to get the point on center, and they don't wander as much just because the whole setup is more rigid. The other thing that's great about the short length drills is that they preserve the Z height. So in a CNC machine, especially one like mine, my G0704, I have a limited amount of Z height. And these help to preserve that so that I can do larger work in it because the drill itself doesn't stick out as much. This is a 26-piece letter drill set. So these go from, on the large end, 413 thousandths down to just over a quarter inch, or just under a quarter inch, 234. And then these are the wire gauge number drills, 1 through 60. So these start out where the letter drills leave off and then work all the way down to very, very tiny little drills down to about, 40 thousandths. Something that I can't imagine I will ever use in a drill machine of any kind. I may use something like this at some point in a pin vise for hand drilling though. But like I said, I thought it was time to finally get some proper sets of drills. I will show you what I've been using if you promise not to laugh. Well, you can laugh if you want. This is a 115-piece set of high-speed steel drills from Harbor Freight, and they are cheese grade. These work great on wood, but for metal work, they're not good at all. They will cut, and if you use a brand new drill and you happen to get lucky, you can make holes with them. They're almost always oversized. They're almost all bent, meaning that they wobble or have a huge amount of run out at the tip. And so what I've been doing is I used these for years for wood, and then when I got into metalworking, as I needed a drill for a project, I just started acquiring quality drills and replacing them individually. Like in the middle of this set is this, which is a Brazilian-made precision twist, quarter inch, which I just went down to my local tool supplier and picked up when I had a project where I needed a good quality quarter-inch hole. And I've just been slowly replacing these one by one. There's the half-inch. And these are jobber length, and I'll probably just continue to do that and acquire the jobber length drills as I need them. But I now have a nice set of number and letter drills, which is all I really use on a regular basis, because when I'm drilling, I'm usually either just removing material for then to follow up with a milling operation, or I am drilling as a pre-drill for a tapping operation. And either way, it's generally a number or letter drill that's prescribed. I have really not found a lot of use for fractional drills. I don't do a lot of metric stuff in my shop, but even when I do, generally there's a number or letter drill that's appropriate for the tap. And if not, I pick up the metric drills one-off. And I may that may be the next acquisition, is a set of metric drills. Next package. If you have never seen one of these before, this is a Heimer Zero Master. Now, Heimer makes a whole bunch of different variants of this basic tool. And what it is if you haven't seen these, if you've watched John Saunders on his channel NYC CNC, you have most definitely seen one of these. But it's a three-dimensional probe, or a 3D sensor. They call it it's a 3D sensor that can be used as an edge finder and to measure the top of a workpiece. So it works just like a normal dial indicator. When you press the plunger in, the dial indicator runs, and you can set a 0 point right in about the middle of the range and use that to locate your spindle. So you put this in the spindle and you bring it down until the dial reads 0, and then you set that as the 0 reference for the top of the workpiece in your mill or in your fixture. The other thing this does, though, is it works as an edge finder. If you push the tip sideways, the dial indicator also runs. It's hard to do when you don't have it solid in a fixture. And the way this works is the ball on the tip is exactly 4 millimeters in diameter, and when you push the ball exactly 2 millimeters to one side, the dial reads 0. So if you got a 4 millimeter ball and you've pushed it 2 millimeters to the side, that near edge is exactly in line with the spindle. So you can use this as a three-dimensional edge finder. You can use it to find the top of the workpiece and 0 your Z in the mill, and you can use it to find any side direction, front, back, or either side, and when you run this down until the dial reads exactly 0, the center line of your spindle is exactly on the edge of the part. I have wanted one of these for a long time, but again, I just couldn't justify the price. Makes a good Christmas present for the shop. Now, they have several different sizes. They have the original, they have their new generation or next generation that they call it, and then they have the Zero Master. And the Zero Master is the smallest overall, meaning it has the smallest dial, but it also has the smallest Z height. That's designed specifically for small machines like mine. And so I think this will be the ideal size for that. Now, this is a 10mm shank, so obviously you need tooling to hold this, either the TTS tool holder for the system that I have, or as we'll see here in a little bit, an ISO taper if you've got a spindle that is appropriate for that. Get this all put back in the box so that it doesn't get damaged bouncing around here on the bench. This is something you will definitely see more of in the future. I've got some upgrades for the mill coming, and we will be using this quite a bit, and more on that to come. Also recently just picked up this single lip tool grinder. This is a clone of the Deckel SO that's been around for years. This one is actually from Hsd, so this is their clone of this tool, and it has a few differences from the Deckel. If you're not familiar with this tool, it has a cup wheel generally, though you can fit other wheels onto it, and then it holds a tool in a tool holder that you can control the compound angles of how the tool then approaches the wheel so that you can grind different geometry onto it. You can use this for sharpening end mills, you can use this for sharpening drills. Generally they're used for single lip cutting and engraving tools. You can grind pyramids, you can grind D-bits, there's lots of different stuff that you can do. And we will get into this in much more detail in a future video because as it comes from the factory, there are a few improvements that will make it better. So to start with, this uses 5C collets. The Deckel actually uses its own custom collets that I don't think are used in anything else, but this tool uses 5C collets. So you take a 5C collet, whatever's appropriate for the tool piece, and put it in here, and you can then mount your tool bit or whatever you're trying to grind. And you have an index wheel, so you can rotate this around as it then approaches the tool, or as it then approaches the wheel, and so that you can control exactly how it grinds, and you've got fine feed. And you can very precisely grind flutes, or you can grind cutting edges onto a tool. And there's a million other things that you can do with this. Now, if you do ever pick one of these things up, one thing to be aware of is that it comes with several wheels. It comes with the diamond cup wheel that's on it. It comes with a stone cut cup wheel as well, and it also comes with a straight wheel. And then if you get one of these and you want to use it for other things, you're probably going to want to pick up a few more wheels. I want to pick up, in particular, a cutoff wheel and maybe some CBN tooling. The way they show you on the horrible videos that come from the factory, they show you how to replace the tool, and they actually tell you to use the wrench and take the wheel off of the wheel adapter, which is just crazy. What you really want is to pick up additional wheel adapters so that you can mount each tool on a wheel adapter and be able to then just swap these on and off the taper easily. For whatever reason, they don't recommend that. All their documentation says to take the wheel off of the adapter rather than to just swap out the adapter. They didn't used to list these extra adapters on the website, but they do now, so you can pick those up. So if you order one of these, definitely pick up some extra wheel adapters when you order it. It comes with a bunch of other things. There's some other fixtures I haven't messed with yet. This comes off, and there's a little XY stage here, and there's a lathe tool bit cutting adapter. There's a swing arm drill grinding adapter that goes right into here, and you can swing the drills. This is very similar to like the Lyle drill grinding machines and other things that you may have seen on other YouTube channels. And then this one also comes with an end mill regrinding adapter. I'm skeptical, but we'll hook that up at some point and give it a try. See, we're gonna look at this in depth because like I said, there are some things that need to be fixed on this machine right from the factory, and we will take a look at that in a future video. I'm not gonna spend any time on it, but you can see down here in the corner, I've also got an Oxy-Acetylene Torch now in the shop, and this is something that I recently picked up because when I do the work on this to improve it, I'm gonna make a tool that I'm gonna wanna do some silver brazing on. And the oxyacetylene is gonna be a lot better than the MAP gas torch that I have been using for all of my heat treating to date. So that will be coming up in a future video. Now, finally getting to the good stuff. This barely got here in time for this video. Came in on Christmas Eve. Gotta love a big box with a very heavy small box in it. What do you think it is? Any guesses? This is a 3 horsepower automatic tool changer spindle for my mill. You'll remember I have a Grizzly G0704, which came from the factory with an R8 spindle and a 1 horsepower motor. And the biggest thing about that has just plagued me endlessly is that the maximum speed on that spindle is 2200 RPM. And so there is just a limit to how fast I can spin tools, which means there's a limit to how fast I can remove material. So as I was making things, you've seen me make a number of things CNC on that mill. And as I make things on that mill, you'll note that I'm constantly speeding up the video because it just takes forever to get anything done. I've had lots of people ask me about whether I'm going to machine and engrave the control panels for the electronic lead screw. And quite frankly, it's something I can't afford to do on a mill with that slow of a spindle. And this is hopefully going to be the solution. So this is a 3 horsepower, 4-pole spindle. So your typical CNC router spindle that runs at high speed really can't be slowed down to do any kind of milling in steel. You can do it, but you're really pushing it because you just can't bring the RPMs down below about 10,000 RPM without losing a ton of power. Those are generally 2-pole motors. This spindle actually has a 4-pole motor. So when coupled with a sensorless vector drive VFD, it should be possible, I am told, to bring this down to a few hundred RPM for drilling and a low, few thousand RPM, 1,000, 2,000 RPM for milling in steel with small tools. And most of what I do is in aluminum, so we'll be putting coated tools in this, specialty tools for aluminum, and spinning them up to 10,000 or 12,000 RPM and just plowing out material. But in cases where we want to work in steel, this should still give the ability to do that. Now this also, even though it's 3 horsepower, is quite a bit lighter than the entire head assembly that's on the mill now. So the plan is to ditch all of that, replace it with this, and then have a fully functional mill with a high-speed spindle like you would see in a router, but a rigid machine like you would see in a milling machine. So we should end up with something very capable, something on the order of kind of the weight and speed and power and capability of some of the smaller Tormach machines with the newer ones with the high-speed spindles. So that is the plan. Not only is this a high-speed spindle, it also is an automatic tool changer. This is an ISO 30 taper in the end, and it uses Hsd style pole studs, and there are pneumatic connectors up on this end for the automatic tool changer and for the purge air. In order to protect the bearings, the case is pressurized. You provide shop air to one of these two connectors on the top, and that pressurizes the case so that any air that gets past the seals is leaking out past the seals, so that any dust that tries to get in, it was just going to be met with that airflow coming out. And so you shouldn't have any issue with dust ingress into the bearings, reducing their life. And then the other port, of course, is to provide the pressure for the automatic tool changer, so when you apply compressed air there, the tool releases and comes out. Let's see what else I got with it. So of course, a spindle like this isn't much good all on its own, so we've got a bunch of stuff that comes with it. The number of parts and pieces that are required to set something like this up and get it running can be quite intimidating, and there will be a whole series of videos on going through that process. Got a very nice cable set that came with it, and this is all pre-terminated with the connector for the top of the spindle, the 3 phases for the motor, a temperature cutout, and ground. Got a bunch of tooling in here. Just as a starting set, I got a bunch of these ISO 30 to ER 32 collet holders. So these are your traditional ER collet tool holders, and I've got a selection of ER collets here, and this will be what we're starting with. Curious, I haven't even looked at how these look. Now, of course, I don't have compressed air, so I can't actually suck the tool in, but you can kind of see how that fits. Yeah, so that fits up in there, and then the automatic tool changer will grab that and suck the taper up. And so we're talking about off the end of the spindle bearings, which are in here, a very short stick out on these tools. So this should be a lot less stick out and a lot more rigid even than the R8 collet that's in the mill now. Of course, to turn a spindle like this, you need a VFD. And the VFD that I have here is a 2.2 kilowatt. That's a 3 horsepower Hitachi. This is the WJ200. And this is the single phase 200 volt version. So I'll run this off of 220 here in the shop, which can pull up to what, about 24 amps, something like that. So we'll have this on a dedicated 30 amp circuit that I'm gonna have to wire in just for this purpose. I've got the circuit, but I don't have the 30 amp receptacles. And so this is not just a standard VFD, this is a sensorless vector drive, which means that it can apply full current to the motor when it's running slowly, and it can sense the position of the motor. You know, without a sensor system, it does it through the back EMF current from the motor. And so you can run these a lot slower than you could with a typical VFD, again, so that we can run this slow and mill steel with it. At least that's the plan. We're gonna have to see how that actually works out. Now, ultimately, the VFD is gonna be in a box down underneath the bench. So I wanted to make sure that I had access to the controls. So I also picked up a remote operator panel. So this is the operator panel for this VFD, and you've got a pot for the speed and all the same buttons and display and menu that you would have on the front of the VFD itself, so that I can mount this up on the head of the mill near where this is, or someplace where it's convenient to get at. And I have my controls for the VFD handy and the display of the VFD. And this just hooks up with Cat5 cable. And of course, to actually hook up the VFD and the pneumatics to run the mill requires a large collection of parts. So I got a NEMA enclosure that I'm gonna put the VFD in and wire all of this stuff together. Got the push to connect tubing for the pneumatics. and then to actually control the air, a double-acting solenoid valve. So this is a 5-port valve, takes compressed air in through one port, and then has 2 ports output. One will go to the VFD to pressure, or to the motor to pressurize the case, and the other one will go to the tool changer, so that when we apply an electrical signal to this solenoid, it'll apply air to the tool changer, pop the tool out, stick a new one in, let go, and it sucks it up in. And then when you're not running the tool changer, the compressed air comes out of the other port and serves to purge the bearings. Now, I'm probably not, at least initially, going to wire this thing up so that I'm running automatic tool changes where the spindle's going over and releasing and picking up tools on its own. I'm just going to use it as a hand tool change, a very quick hand tool change, but I still want to wire it up electronically for one simple reason, and that is if I am using an electronic signal to fire the pneumatic valve to release the tool changer, then I can wire that interlocked with the VFD. So the VFD has a relay output, and I can configure it and wire it up so that it is impossible to release the tool if the motor is turning. Only when the VFD is actually stopped would it then engage the power to the switch to be able to hit the valve and release the tool. And that's important because I do not even want to think about what would happen if I let go of a tool when it was spinning at 12,000 RPM. And let's see, that's the valve. The valve's 24 volts, so we need a 24 volt power supply. So I went ahead and figured we'll do this one right, unlike some of my other projects where you all have made fun of me for attaching a wall transformer someplace in the box to provide 12 volts. In this case, it's 24, but it's actually a DIN rail mount power supply, so got a proper one of those. And then a very large number of little bits and pieces. Some DIN rail fuse holders, 30 amp fuses, all the pneumatic parts you can imagine. We've got some exhaust diffusers, so when the valve fires, the air, compressed air isn't just released to atmosphere, it goes through a brass diffuser to release the noise, or reduce the noise. We've got some push-to-connect fittings. Got some cable glands for cables coming in and out of the box, some ferrites to reduce the electrical noise, and someplace, got so many boxes everywhere right now, I can't keep track of it all. 24 volt fan to ventilate the case, a bunch of DIN terminals, and to reduce the conducted electromagnetic interference and radio frequency noise, an actual proper 2-phase noise filter. And again, this is, I went ahead and sprung for the proper DIN mount one rather than the screw mount one, so this will all go in the NEMA box on DIN rails and should be a much neater install. And again, we will get to all of that, but not today. As I've been shopping for tooling for this spindle, I did encounter one dilemma that perhaps somebody out there can help me with. This is, of course, an ISO 30 taper that uses an Hsd pole stud. But from what I understand, the ISO 30 taper is exactly the same as the BT 30 taper. So I went ahead and picked up some BT 30 keyless drill chucks. So these ones I think are from Tormach. It's got the BT30 taper and the tool changer geometry and a drill chuck on the end. And of course, these come without pull studs because you have to get the appropriate pull stud for your application, which in this case would be an Hsd pull stud. Now the taper fits properly in the spindle, and so we get a nice clean fit, which is exactly what I expect, but we need to get the appropriate pull stud for this. So I picked up some Hsd pole studs. In fact, I picked up a bunch of them from actually 3 different suppliers. And here's what I discovered. See if you can see this. The pole stud itself we've got the pole stud at the top. In this case, it's got a radius on the undercut because that's how the Hsd pole stud is shaped. It comes down and we have an M12 by 1.75 thread. And then there is a small shoulder at the top of the thread that fits into a register surface in the back of the tool holder. And so when I go to thread this in, it doesn't fit because the ISO 30 Hsd studs have a 13 millimeter register on the tool holder, but it's only a 12.5 millimeter in the back of the tool. So as far as I can tell, ISO 30 tools have a 13 millimeter register and the BT 30 tools have a 12.5 millimeter register. So presumably one can buy Hsd Pole Studs with that 12.5 millimeter register size. I haven't been able to find them, and maybe I just haven't figured out the right things to Google for. If you know the solution to this, go ahead and leave a comment down below and let me know. I have considered the possibility of regrinding these. These do have centers in them, so it'd be relatively easy to regrind that down. I really don't want to screw around with that. And even if I did, it would only be for low speed tooling like the holder for the Heimer, which should be 0 speed, or this drill chuck or a couple of drill chucks, which would be very slow speed. I certainly wouldn't want to do that and spin something up to 12,000 RPM. But if you know how to get Hsd Pole Studs for BT30 tooling, let me know. I can find lots of sources of people using the tooling. I can see that the taper fits perfectly. The dimensions all appear the same to me. I just can't find the right Hsd Pole Studs. So if you know where to get them, let me know. Or if you know that this is completely impossible and I'm an idiot, let me know that too. I'm sure you're probably already typing that though. That's all I have for you today. There are some other new things around the shop, but I'll leave those for future videos. If you enjoyed this video, or if you're interested in any of the upcoming projects that I mentioned, give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.